Hi everyone. In this video, let's solve the problem Leetcode number 20, which is valid parentheses. So the question says that given a string containing just the characters opening parentheses, closing parentheses, opening square bracket, closing square brackets, or opening and closing square flower brackets, we have to determine if the string is valid. So the string is valid if each of the opening brackets must be closed by the same type of closing brackets, and opening brackets must be closed in the same order, and every closed bracket has a corresponding opening bracket of the same type. So these two are, and then vice versa. So if, for example, right, if I take this example here, so something like this, we have an opening parenthesis, we have a subsequent closing parenthesis, opening square bracket, closing square bracket. Also similarly for the flower brackets as well. So this is true. But if we have something like this, right, so it's false because there's an opening parenthesis, but it's closed by a square bracket, so it's false. It should be closed by the same type. And if we have this way, this is also false because we can't start with the closing parenthesis. It should always be opening parenthesis followed by its matching closing one. So now this is false, but something of this sort where we have, yeah, so this is true because it's closed in the same order, right? So we have an opening parenthesis, an opening square bracket. So the square bracket is immediately closed by its closing square bracket, and then finally this last parenthesis closes the first opening parenthesis. And the the typical way to solve these problems is via stack, because it kind of helps keep track of where if we have encountered a closing and opening parenthesis or not. So let me just walk through the ideology, and then we'll just write pseudocode for that. So if I take the same example which they've given in the question, this one, right, the first one here. So this this way is, yeah. So if this is S, we get over each character C of S, sorry. If it's an opening parenthesis, or an opening bracket, we just add it to our stack. But the second time we have a closing parenthesis, right, this one. So we need to check if this closing parenthesis matches the element at the top of stack, which is stack of -1, closing parenthesis is equal to opening parenthesis or not. So if it, or is it matching opening parenthesis or not? Okay. So if it's its pair, right? So if it is indeed its pair, now we can pop this out of the stack. So which means that whenever we actually find a particular closing bracket for an opening bracket, we can pop it out of the stack. So whenever there's a pair, we pop it out. And you might have got the idea, right? So each time we add then pop out the opening brackets, in the end, if we have an empty stack, then it means that we have a set of valid parentheses. If we have any opening brackets left out, it means they don't have the corresponding pair, right? So in that case, it wouldn't be valid. So we check this if our particular closing bracket, if it's equal to if it pairs up with the element on top of the stack, then we pop it out. So here what happens is we have this. So this gets popped out. Okay. And then third step, we have another opening close bracket. So we just added. Fourth step again, we have this closing square bracket. So now closing square bracket pairs with this opening square bracket. Okay, so it actually pairs with it. So now we can pop the opening square bracket also. So until now you can see that our stack is empty, which basically, even if you go through one by one, right, it means that the parenthesis until now is valid because we have a pair for each of the opening brackets. And similarly, if you go ahead, we have opening flower bracket, and then we have an incoming closing closing flower bracket. So this one gets popped because there's a pair. So now we reached the end of string. We are here, and the stack is empty. So we have valid pair out valid parenthesis. But let's just take up another example, right? So if I have s is equal to this one this way. So now, okay, this closing parenthesis comes sits right here. Oh, sorry, the opening parenthesis comes and sits in the stack. So now when we have a closing parenthesis coming in, so this pairs up with what is on top of the stack. So we can remove it from the stack because its pair is there. But in the next step, we have an opening square bracket which comes and sits inside here, but it's like the end of the string, so there's nothing in front of this, right? So when we reach the end of the string, there's still one element in stack, so it's not valid since we don't have a pair for this opening square bracket. So I hope it's clear now. And there is the time complexity for this is often for sure because we just iterate over the string once. The space complexity depends. So if for the stack in the stack, right, so each element can be um, present just once. So basically the worst case time complexity of stack when we have all, let's say, opening brackets would be often. But this also depends on whether we use a hash map to track pairs or not. So essentially, we can keep a hash map to track the pair. So what I mean to say is, once you get a closing parenthesis, right? So in this case, so we need to actually know what is its corresponding pair, what is its corresponding opening parenthesis, which like logically we know it. I mean, practically we know it, but logically in code, this is how we maintain it. So we basically say that for this closing parenthesis, this is the opening parenthesis. So now whenever we find this closing parenthesis, we actually check its value, which is this one. We compare it to the element on stack minus one, top of the stack. If it's equal, then we pop. So this is the basic logic. Similarly, we have for the other two types as well. Hope it's clear now. But instead of this would take another, I mean, constant space. But instead of this, what I have coded and what I'll show is just comparing it manually using OR statements. So this was the entire code, and I mean the entire description or explanation, and it's the most efficient method. And yeah, now let's go to the code. So coming to the code, we keep a stack, which is basically an array, and for each character in our string, if it's belonging to one of these three opening brackets, then we put it onto the stack, open it out to the stack, push it to the stack, and else if it's a closing bracket, if this if the stack is not empty, so this this case I showed here, yes, this particular case showed here, when we push this for the first time, right? So in this case, the stack is empty. This is not allowed because we can't start with a closing bracket, or stack is not empty, or if if it's equal to a closing parenthesis and the top of the stack is not equal to an opening parenthesis of this kind. So, for example, we have this which is pushed first this way, but when we get this closing parenthesis, right? So it comes to this condition. It's a proper closing square bracket, but the element on top of the stack is an opening parenthesis this way. So this is false because then our parentheses won't be valid anymore. So we just return false and we don't check anything else. But if we have a proper pair, if we have this opening brackets, then we have the same closing parenthesis, and the stack of top is equal to this closing parenthesis, then we pop the opening one from the stack, like I showed you in the diagram. And finally, like I said, after we go through all the characters in the string, if the stack is empty, then our parenthesis is valid. If it's not empty, then it's not valid. So this was uh, the entire approach, and thanks for watching. I'll see you in the next video.